All right, we're going to be looking first at Descartes' rule of signs. Now, Descartes' rule of sign tells us the number of potential zeros that a function might have that are positive, negative, and imaginary. So the first thing we're going to look at are the potential number of positives. Descartes' rule of signs says that I should look for the sign changes between my values inside my function. So I look at the original function. And this is a quintic function because its biggest power is to the fifth power. And this is an imaginary positive out here, but I can't forget that. It's very important that I don't forget that there's still a positive sign in front of the very first guy. So I go from positive to positive, no sign change. I go from positive to positive, again, no sign change. I go from positive to positive, no sign change, and I go from positive to negative. There's a sign change. We go from negative to negative, no sign change. So the possible number of positive zeros will be 1. Now, in Descartes' rule of signs, it also says that this decreases by an even number. So I'll always subtract this by 2. But if I were to subtract 1 by 2, I'd end up with negative 1, and we can't have a negative quantity of zeros, so I stop at 1. Okay? The next thing I'm going to do, and I'll write that all out when I make a chart. The next thing I'm going to do is test the number of negative real zeros. So I need to plug in a negative x into all of my x values. So I'm really looking at 2 times the quantity negative x to the fifth power plus 4 times the quantity negative x to the fourth power, and so on. Let me quickly plug those all in for you. And now it's also important to recognize that anyone that has an even power, their sign will not change. But if there is an odd power, their sign will change. So like this very first one here, 2 times the quantity negative x to the fifth power, because 5 is an odd number, this becomes negative 2x to the fifth power. The next one is negative x to the fourth power. Because it's an even power, his sign will not change. Again, negative x to the third power, his sign will change. We have negative x to the second power, his sign will not change. The reason this is happening is because an odd times an odd is, a negative times a negative is a negative number, and it's going to become a positive. So it's going to stay the same. Next we have negative 35 times negative x, so this becomes positive 35x, and this is also still negative 70. I'm now going to look at the sign changes here for my negatives. So we go from negative to positive, here's a change, positive to negative, here's another change, negative to positive, here's another change, positive to positive, no change, and positive to negative, there is a change. So now the odds, the positives had 1, the possible number of negative zeros will be 4. Now, remember I told you that we need to subtract this by an even number according to Descartes' rule of signs. So 4 could also become minus 2, so 2. But again, we are going to subtract by an even number, so 2 can become 0. The next thing, the most helpful thing that I like to do with my kids is to make a chart. So I'm going to make a chart where I'm going to list off the possible number of positive cases with negative cases with imaginary cases. And the total for all of these should always be the highest degree of your polynomial. So all of these totals should add up to 5. So we have the case of positive where it's 1. We have the case where negative is 4. 1 plus 4 is already 5, so in this case there would be no imaginaries. But there's more cases to address because we have the one where we decrease by an even number. We also have the case of 2 negatives. There's no other case with a positive, so he's also 1. 1 and 2 is 3, so therefore to add up to 5, my imaginaries would be 2. The last one I got to worry about is this case of 0 possible negative zeros. So we have 1 positive, 0 negatives, and therefore 4 imaginary, so we add up to 5.